Hello, Geometry. Welcome to 6.1. I think this is like the 5th time I've redone this video. I'm having technical issues. If I can't get this to record, then we might have to go back to unflipping the lessons. Let's hope that doesn't happen. So everybody say hi, Blaze. Blaze is with me today.
Hello.
We are using similar polygons. Just like triangles, the angles are congruent. The sides are proportional. So yes, I already filled this in. I've printed off so many of these. I'm tired of using all the ink. So sorry about that. If I'm talking too fast or moving too fast, you need to pause it, copy it down. So here we go. I can use proportions. So we will be solving proportions, and lots of them in geometry. And I can use scale factor. Remember, that would be like your first ratio within a proportion. Here we go. Okay, with the warm-up. We want to solve this proportion. We can do it in two ways. Notice you can multiply the bottom by 6. That means we can multiply the top by 6 and get 72. I like to cross multiply and solve because not all the time will a proportion be that obvious. So 12 times 60 is the same as 10 times x. 10x is equal to 720. Divide by 10, you get 72. So again, if you can see the multiplier, go for it. Okay, now you did problems like this in 7th grade. The scale on a map is 1 centimeter to 10 miles. I know the units are different. You don't have to put it in the same unit. Just write it as 1 centimeter over 10 miles. If you have centimeters to miles, keep it in the same way, centimeters over miles. The actual distance between two towns is 4.3 miles. So since miles is on the bottom, you put 4.3. What is the actual distance on the map? So the map's on the top. The distance for the towns are on the bottom. Cross multiply and solve. 1 times 4.3 is 4.3. 10 times x is 10x. Divide both sides by 10. The map, those two towns will only be 0.43 centimeters apart, so really close. All right, now a model train engine is 9 centimeters long. The actual engine is 18 meters long. So I wrote 9 centimeters to 18 meters. What is the scale of the model? Reduce it. 1 centimeter to 2 meters. You can write it like this also. So far, it's still recording. All right, so here's our key vocabulary. Two polygons are similar if they're corresponding. That's so important. Angles are congruent. I don't have my highlighter. I don't know where it's at. And the corresponding sides are proportional. So notice AB goes to EF. Now, if the shapes aren't kind of shown in the same way, like the same direction, sometimes they turn them around. It gets really confusing. Look at your similarity statement. A is going to correspond to E. B is going to correspond to F. See this? Angles. A is congruent to E. B is congruent to F. C is congruent to G. D is congruent to H. And then the side lengths. AB goes to EF. BC goes to FG, etc. Now, what is the ratio from ABCD to EFGH? 10 to 20. It reduces 1 to 2. All right. Now, example 1. Okay, sometimes the triangles are drawn in a way where it's hard to tell what side corresponds to what side. So what I like to do is actually circle them. A goes to Y, B goes to X, C goes to Z. So I wrote those out. So again, you might want to pause this and write it out. And then jumping down to C, the corresponding side lengths, AB goes to YX. Be careful. It's not in alphabetical order like they usually are. So you have to write them the exact way that the similarity statement tells us. BC goes to XZ. And then AC goes to YZ. So if you look at this, AB, which is right here, goes to YX, which is right here. Okay, so the reds go together. BC, which is 12, goes to XZ, which is 16. These two go together. And then last but not least, do I have a blue? We have a blue here. The 9 will go to the 12. Okay, so check the ratio of corresponding side lengths are equal. So from the small to big, 15 goes to 20. See how it's nice when you color coordinate it. 12 goes to 16, and then 9 goes to 12. They all reduce to 3/4. So far, so good? Okay, so that was page 1. Now let's look at page 2. Hopefully you're following along. Now, if two polygons are similar, then the ratio of the lengths of the two corresponding sides, again, that's so important, is called a scale factor. In example 1, the common ratio is 3 to 4. This was the scale factor from ABCD to triangle YXZ. Now, if two triangles are congruent, what is the scale factor? 1 to 1, because the side lengths will be exactly the same and they'll reduce. All right, so let's look at example 2. Yeah, there's a lot written here. We can handle this though. Okay, so if you'll notice, the figures are arranged in a similar way. This has one arc, that has one arc. It's kind of hard to tell how many arcs these have, but they are similar. So AB is going to correspond to EF. BC is going to correspond to FG. CD is going to correspond to GH, and DA corresponds to HE. Okay, so now I'm going to write the corresponding sides. 5 to 2.5, can you see that? 6 to 3, 7 to 3.5, then 4 to 2. They all reduce to 2 to 1. They all have to reduce to the exact same ratio of sides. So it can be written this way. So now, right, ABCD is similar to EFGH. This is your similarity statement. Notice the similarity statement only has a wave, no equal sign, because that would mean congruence. All right, this was the tough one. Okay, and this is when it stops recording every time. It's driving me crazy. So they tell us the similarity statement. So I notice DC goes to KJ. Okay, so this is kind of like flipped around, I guess. 4.5 to 3. I circled these because those are the only two with the corresponding sides that both have numbers. Notice there's a letter or a number. So I want to find out all of these. ABCD are side lengths. EFG are angles. So to find A, we're going to use the 4.5 to 3, notice, for every single one of these. So 4.3, and then A corresponds to 2. Okay, so cross multiply and solve. A equals 3. Now to find little letter B, where is B? B is right here. Okay, 4.5 to 3, B to 1.5. Cross multiply and solve. Double check these. You get 2.25. Now little c is right here. Okay, so again, 4.5 to 3, 6 to c. Cross multiply and solve. You should get 4. And then D for donut, that's down here. Okay, so these two sides correspond. 4.5 to 3, 3 to D. Cross multiply and solve, you're going to get 2. Now, the angles are going to be congruent. So where's little e? Little e is right here. Okay, so in the diagram that's B, that corresponds to H, so 92 degrees. So letter F is up here. In the diagram it's letter K, which corresponds to D. That would be 120 degrees. And then G for goat, greatest of all time. That corresponds to L and E, so that would be 40 degrees. So far so good. We're still recording. Okay. Perimeters of similar polygons. Okay. Two polygons are similar, then their scale perimeters are proportional to the scale factor between them. Okay, so now this is going to be different from area, so I'll probably bring that up in class. All right, so if you have two sides ratios from 4.5 to 3, if you find all the perimeters, it'll reduce 4.5 to 3. All right, next page. Still crossing my fingers. It's still recording. 3's a charm. Okay, so here we go. You are constructing a playground area. Whee! Get rid of that extra sheet of paper. I don't need it anymore. Okay, so a playground is rectangular with a length of 25, width of 15. So 25 meters by 15 meters. And it's a rectangle, so we can put in some little squares there if you choose. Find the scale factor of the new play area to playground. Okay, so that would be 25. Oh, wait. Okay, the new play area. So I got to write that one down. We don't know that side length yet. It's going to be 10 meters in length. We don't know this. So it's 25 to 10. That is going to reduce, divide both by 5. 5 to 2. Okay, now find the perimeter of the playground and the new play area. Well, first of all, we probably need to find this, right? So 5 to 2 is equal to 15x cross multiply and solve. 5x is equal to 30, x equals 6. Okay, do you remember how to find perimeter? Okay, so let's go ahead and find perimeter of the original playground. If you remember, I have two 25s and two 15s. You have to add them all up. So 2 times 25 plus 15. Or you can say 2 times 25, 2 times 15, your choice. 2 times 40, you get 80. And that was in meters because it's a distance. So if I had a fence going around here, it would be 80 meters of fencing. Now how about the new area? We're really going to cut this back for these kids. All right, so if this is 10, this is 10. We have 20 plus 12, 32. But write it out with our formula. 2 times 10 plus 6 equals 2 times 16, which is 32. They really did cut back. So who knows what they're using the space for? Maybe a dog run, a dingo run next to the play area. Okay, here we go. Corresponding lengths and similar polygons. Of course, this keeps coming up the same stuff over and over and over. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons is equal to the scale factor of similar polygons. Okay, so you've probably caught on to that. Notice any two congruent figures, it's 1 to 1. We've already done that. Okay. My little congruent symbol. For instance, like these two. Notice this is 10 to 10. The angles are the same. Side lengths are the same. They're going to be congruent. So this is like an angle side situation. And I'm going to put the congruent symbol there. The scale factor is 1, because if we reduce those, you get 1 to 1. You could say that these are similar, but they are also congruent. Okay, but you can't say vice versa. All right, last example, and it's still recording. Woo! Okay, just in case, if it stops recording, NL is equal to 21. See if you can figure it out. But here we go. Find the length of this altitude. Now they're trying to tell us that this top triangle is similar to the bottom triangle. So let me find the ratios of sides. MN is 30. That goes to RS, which is 20. That's equal 3 to 2. And then let's double check. 27 to 18. Divide them by 9, you get 3 to 2. Okay, so it is correct. We double checked. So that means also x goes to 14. Cross multiply and solve. 2x is equal to 42. X equals 21. So that's the length of NL. All right, cool. This finally recorded. Watch me screw it up. Here's our homework, and there's our Common Core standard, and everybody have a nice evening.